address those issues. I'll walk through a little bit of what some of those are, so that you understand kind of what's happening. But for version 1.1, we already went ahead and released that in September. So if you have done a new pull of any data since September, mid-September, around the 20th, this would be the data that you're seeing. And we're working right now on version 1.2, which will be ready via the API in December. So we'll have specific dates for that we'll share with you all so that you know when we have releases, when we have updates, when they're coming, and what you can expect. In version 1.1, as I mentioned, we had about 3.5 million properties that we held back at launch. We were able to push these 2.5 million of those at our 1.1 version. In addition to that, there were close to 1 million properties where the flood factors may have changed slightly. Some of the depth statistics may have changed slightly. Generally, they stayed pretty close. They're within 1 or 2 flood factors, and some of that is just kind of related to the way we generate the flood factor based on different thresholds. So if we see something move from 23 inches of flooding to 24.5 inches of flooding, that can make a difference on something like a flood factor. So this is where we see some of these differences. I'm not sure how many of you work with the actual risk score number that we create, or you're probably more likely working off of depth statistics and things like that. And those didn't change significantly. Part of the reason we did see some changes was because of the way we calculate our statistics. We try to use the building footprint data wherever it's available, and then use parcel centroid statistics where it's not. So, you can see in the example here, sometimes that makes a big difference because the parcel centroid might not be in flooding, but the building footprint is. So kind of for a variety of reasons and some updates, we did see some of this stuff changing, and that's why there was some changes in our depth. Also, another thing that happened, we identified there were certain areas where the ocean layer that we used was a little bit imprecise at some of peninsulas and things like that, sticking far out into the ocean or major bodies of water. So we cleaned that up pretty quickly and got that involved, updated in version 1.1. Version 1.2, which we're working on right now, the big thing for that, that I'm sure you all will be interested in, is average annual loss. So Jeremy and his team have been hard at work taking the depth statistics that we have and then applying Army Corps curves, depth damage functions to generate a value, an actual dollar value associated with these potential losses, and applying that over time. So this is a new feature that we will have in Flood Factor a little bit later on, maybe not immediately with the version 1.2 launch, but will be coming in the December or January timeframe. And then there are a few other things, pretty small stuff, but things you might be interested in. When we originally created our historic coastal events, we had kind of a sharp drop off where we cut off our edges. So then in some cases you'll see, if you're looking at the existing data right now, you'll see that there is flooding, and then immediately adjacent to that, on a very clear linear pattern, there is no flooding. So we're cleaning that up and extending out our interpolation a little bit more. In addition to that, we're also making some updates specifically to our representation of Hurricane Katrina, which this was one that we've kind of, it's been very well mapped in the past. The recreation that we had didn't exactly match in a few areas what the actual experience was. So we got new high water mark data and extracted that from a few different sources, and have been able to create a more accurate representation, particularly within New Orleans itself, which is, obviously a very difficult and tricky area to model because of all the infrastructure that's already there. So, but we feel pretty confident in the new version that will be coming out in 1.2. And then ultimately we'll have a version 1.3. We're trying to work on a quarterly basis. The 1.1 came out 2 months after launch about, and then 1.2 will be about 2.5 months after that. And now we're starting to get on a quarterly basis. When we look at 1.3, we'll have a few major updates. one of which is some additional historic events, particularly along the coasts, where we look at hurricanes like Harvey, Florence, and Matthew, where there was a lot of flooding associated with these, but it wasn't necessarily from the surge. Our first round of historic events were in the coastal side were explicitly modeling surge, but not precipitation-based flooding. So with Harvey in particular, the surge hit Galveston, the rainfall hit Houston and caused all the flooding in Houston, which is what people think of when they think of Harvey. So that's why we haven't released realization for Harvey yet, because we're merging those two together. And then we'll be doing the same for Florence and Matthew and potentially some other events too. These are the ones that were most driven by precipitation, so we've focused on these. And then we'll be having some other updates. We're acquiring new elevation data in places where we've identified the elevation data being a little bit old, and rerunning some model updates there. So this is an image of Scottsdale, Arizona, with comparing old USGS elevation data, which was actually from the 1970s, to a LiDAR DEM generated in 2015. You can see there's a much better definition and accounting for obviously all the development that's happened in those almost 40 years. So these are the sort of updates that we'll be making all the time. And then ultimately we'll have a version 2, which we're going to expand to Alaska, Hawaii, and Puerto Rico. We'll have incorporate new flood control data, new elevation data, and add some additional hydrologic features that are some of the model limitations that we've identified that we're continuously working to improve. And then we'll also shoot for a version 3 even further down the road. We're looking at 2022, where we will update our climate data from CMIP 5 to CMIP 6. And of course, we'll have various other model improvements in that time. But that's obviously a long ways out. But to start working with the climate data, we need kind of a longer lead time with that. So that's why we're charting that out at the moment. But as you see, we'll have the quarterly updates in between these as well, in between the major version updates, version 2 and version 3. And that's really what you can look forward to from us in the coming months and years.
Awesome. Thank you, Mike. We'll turn it over to Penny now, and then just to reiterate, we'll be online at the end of the hour if folks have questions about the model or anything else.
All right. Let me share my screen. Can people see my screen?
Yes.
Yes.
Okay. Thank you, everyone, for attending this workshop. It's very exciting to see the updates that First Street is coming up with, because our project has benefited a lot from this data, but definitely have not fully used the power of property level flood risk. And so it's very exciting to see these updates, and hope to take advantage of having access to this data more in the future. Today, I'm going to present a project that's called What's at Stake? Understanding the Role of Home Equity in Flood Insurance Demand. This is a joint paper with Philip Mulder, who is currently a graduate student at Wharton Applied Economics. Oh, and I forgot to introduce myself. I'm Penny Liao. I'm currently a postdoctoral fellow at the Wharton Risk Management and Decision Processes Center. So with this audience, I guess I don't need to emphasize that flood risk is becoming very serious in the US. Millions of homes are exposed to these risks, and they are projected to grow. This has important implications for the housing finance system. Especially during hurricane seasons, we sometimes see these news stories about how homeowners, after their home is hit by a disaster, would have to abandon their home and move elsewhere. And there are a lot of evidence suggesting that disasters could increase displacement, foreclosures, and delinquencies on mortgages and debts. Recently, the New York Times has done a new story on how the rising seas can threaten an American institution, which is the 30-year mortgage. So because of the severity that flooding potentially can cause, there has been a lot of recent interest in looking at how the housing finance system is responding to increasing flood risk. And especially there's a recent literature focusing on studying how lenders and banks are responding to it. There are studies on how they change their lending practices, as well as on how they try to transfer the risk on their book to the federal government by securitization. In this paper, we're going to look at the other side of the mortgage system, which is leveraged homeowners. We asked the question, how do leveraged homeowners manage their disaster risks? In particular, we're going to explore the connections between the homeowners' housing finance obligations and their disaster insurance demand. Our research question is, how do home equity affect the demand for flood insurance and why? Here, I want to walk through the logic of why or why not home equity might affect the demand for flood insurance. So home equity is basically a homeowner's stake in their property. It includes the value of the land plus the value of the structure, but minus the outstanding mortgage balance. Now, when we think about flood insurance, what it covers is really the disaster risk to the structure. So suppose I have a home that is damaged by flood, and if I have flood insurance, the payout I'm gonna get from the flood insurance is gonna be covering the cost to replace the damaged portion of my building. And so what is at stake here is really the value of the structure that would be subject to this risk. So conditional on the value of the structure, home equity has nothing to do with the payout or the benefit of a flood insurance, and therefore, theoretically, it should be relevant for whether people want to buy flood insurance or not. However, as I have mentioned before, because flooding can increase default, and in a default, the household actually loses the home equity. And this connection, this connects home equity to flood insurance demand. If a homeowner has low home equity, then after a flood, the homeowner faces the choice of either paying the repair cost, which can be very high, to their structure, or defaulting on their mortgage when they're liquidity constrained, when they don't have insurance. Now, in this case, the default actually caps the homeowner's loss to the home equity level, which is low. And so with low home equity, the default can actually serve as a kind of implicit insurance that caps their loss. But with higher home equity, what happens is that it changes the homeowner's incentive to default, because homeowners now would want to protect themselves from the possibility that they have to default. And so different levels of home equity changes the homeowner's incentive to buy flood insurance. And of course, all of this is theoretical, and we show this in a piece of theory in the paper. But our main task in this paper is to establish whether there is an empirical link between the two. And that would provide insights into the homeowner's decision-making about buying flood insurance. We are going to study flood insurance demand in the NFIP, the National Flood Insurance Program, between 2001 and 2017. Now, the challenge we're going to face is, of course, that home equity is going to be correlated with a lot of determinants of flood insurance, such as income level or education level, financial literacy, risk preference, etc. So what we're gonna do as a solution is we're gonna exploit structural bricks in home prices during the housing boom of early 2000s. What it means is that during the housing boom in different housing markets, there are different levels of boom. So for example, here in New Haven, Connecticut, the housing price just grows smoothly over this time period, whereas in Naples, Florida, there is a clear trend break somewhere in the middle of 2004. And there's a sizable literature studying these booms, and they found out that the nature of these booms is basically that it's driven by speculative activities, while the underlying economic fundamentals are running smoothly. And so this provides us with an ideal setting of exploiting only the sudden changes and unexpected changes in home prices while controlling for the underlying characteristics. So, and also the other thing is that around this time, what is happening is that there has been rapid land value appreciation, and that caused increase in equity, as you can see here, that the solid line, which represents household equity, tracks closely home prices. And we're gonna run a difference in differences specification, looking at insurance take-up changes in markets that have smaller booms and compare that with markets that have medium and higher booms. And this is how it looks like in the raw data. So on the x-axis, we plot the size of the housing boom. And on the y-axis, we plot the change in flood insurance take-up between 2002 to 2007. And here, each circle is an MSA. So here we can already see that there is a positive relationship between the two. And we're going to drill into this relationship in the rest of this project. So to give you a preview of the results, we find that take-up increases during booms relative to the MSAs with smaller or no booms. And they follow very similar dynamics relative to the timing of the boom. So that reassures us that there is a direct relationship between the two. We then estimate the home price elasticity of take-up to be 0.3, and this is comparable to a lot of the factors that are considered to be important for flood insurance take-up. We also find that this effect is mainly driven by take-up outside of the special flood hazard area, which is the 100-year floodplains. Inside this area, if the household has a federally backed mortgage, they are required to have flood insurance by federal regulation. The fact that we find our effect is mainly driven by take-up outside of SFHA suggests that our effect do reflect voluntary purchase decisions by homeowners. We then test for the mechanism of this relationship. I have already introduced the default incentive mechanism previously. We also test another major mechanism that could explain this, which is the liquidity effect, that housing boom allows homeowners to have better access to liquidity, which allows them to better afford flood insurance. In terms of contributions, our paper provides, to our best knowledge, the first estimate of causal effect of home prices on flood insurance take-up. This is relative to the literature which has looked into this relationship, but mostly provides correlational statistics on it. We present and test a new mechanism where implicit insurance from mortgage default can affect the demand for flood insurance. And this runs parallel to the literature in healthcare and other settings where you have various mechanisms that create implicit insurance and that crowd out formal insurance demand. And then our results also have implications for who bears the burden of disaster costs. And this is important as the risk is increasing. In particular, our result is consistent with this existing literature that looks at climate risk and the mortgage market and find that the lenders are transferring their risk. And our result shows that, shows the mechanism by which the homeowners and the insurance company do not fully bear the risk that is out there. And some of the risks are getting transferred to the lenders. So we use 4 major sources of data in this project. The first is the National Flood Insurance Program Policy Database. It includes the universal policies written by NFIP over this period, and NFIP accounts for over 90% of flood insurance written in the United States. So this is the vast majority of the market. This database is really cool that it contains detailed policy characteristics associated with the policies that we can use to split the data in various ways. We then take the MSA level housing boom structural break instrument from Charles Hurst and Noto Dicto for our housing boom instruments. And we use FHFA MSA home price index. And the last major data source that we use is the flood risk measure from First Street. So we use these data in 2 ways. I will talk in more details later, but one is to use it as an important control, and the other one is to use it in a heterogeneity analysis. In the end, we have a quarterly panel of 278 MSAs during 2001 to 2017. Our empirical strategy is an expanded version of the difference in differences, or it looks like an event study. We regress the outcome variable on a set of interaction terms. So these are the interaction of event time indicators, which indicates the J's quarter relative to the start of the housing boom, with the size of the boom. So if the housing price change during the boom has nothing to do with insurance take-up, then what we're gonna see is that these beta J's are gonna be very close to 0. But if they do have a relationship, then these beta J's is going to trace out the dynamics of the outcome variable during the boom. And then we control for a vector of time varying characteristic of the MSA, which is the X variable. Here, we include the housing transaction volume to control for the effect of housing turnover. We include log of income so that we control for the fact that maybe people get higher income during the housing boom. We also control for an average risk measure, flood risk measure, interacted with a year dummy to allow for MSAs with different underlying risks to behave differently based on their risk over time. And then we control for MSA fixed effect and quarter year fixed effect. Our identifying assumption is that the housing boom should be uncorrelated with changing flood insurance demand outside of the home price channel. And we will discuss a bit more about various ways it can fail and how we check whether it fails or not. So if we run that regression over housing price, here's what we see. We see that there is essentially a very flat pre-trend, and then at the beginning of the housing boom, the price goes up in a boom and bust fashion. It peaks around the end of the 3rd year. So this is expected because essentially we use a housing boom instrument, and this shows that the boom instrument captures the timing and the size of the boom well, of the housing price change well. Now, if we turn to NFIP take-up, this is what we find. Similarly, we find a pretty flat pre-trend, and then we see the same increase and decreasing pattern over the same time period, and it's peaking around the same time. Now, there are several ways where the housing boom could affect flood insurance take-up outside of the home price channel. One is that maybe it just increases turnover in the SFHAs. And because SFHAs have the federal regulation of purchase mandate, they have to buy insurance, and that would mechanically increase the demand for flood insurance. The other concern is that maybe the housing boom increases new construction. And if you have more buildings at risk, of course, you're going to have more flood insurance take-up. We then split the sample and look at the count of non-SFHA policies, so they're not subject to the regulation, on buildings that are built before 2003. So these are not new constructions. And we essentially see the very similar result. It's noisier, but the magnitude and the dynamics are the same. Next, we are going to move on from a difference in differences framework to a two-stage, to an instrumental variable framework where we use two-stage least square to estimate directly the effect of home prices on flood insurance take-up. And we use the structural bricks as instruments. So in the first column, we show you the results for the full sample. And we find that basically this estimate means that 1% increase in home price is associated with 0.3% increase in flood insurance take-up. Now, if we compare this magnitude with other factors that have been estimated in the previous literature, we find that this home price increases by 1% roughly have the same effect as flood insurance premium decreasing by 2%. We also find that we know that if an area is hit by a hurricane, flood insurance take-up increases because people learn about the risk. And we find that turns out that being hit by a hurricane is approximately equal to home prices increasing by 4.8%. Given the variability in home prices, this suggests that home prices do have a pretty substantial relationship with flood insurance take-up. Next, we split the sample into SFHA and non-SFHA. And here we see that non-SFHA has a much larger impact than SFHA. So we have established that there's a positive relationship between home prices and the flood insurance take-up. Now we're going to look into the mechanisms. And as I've explained, the first mechanism we considered is that there is higher home equity during the housing boom, and that provides greater liquidity to households. And they can then access, pay for flood insurance. So here we're going to test the prediction that there should be an increase in one-year renewal rate at the beginning of the boom. So in the insurance literature, insurance non-renewals are often associated with liquidity constraint. If this channel is actually the main channel creating the relationship we see, then we are also going to see a decrease in non-renewal and an increase in renewal rate. And we pick 1 year because 1 year is a very short time frame that households would not think they learned something about their local flood risk. And then we also test the default incentive mechanism. The first prediction we're going to test is that we should be seeing a larger effect in states with judicial foreclosures. These are state laws that dictates that any foreclosure procedure has to go through legal review. And in these places, homeowners generally get more protection during a foreclosure. And past literature have found that these states have higher foreclosure rates. And homeowners strategically default more. So these are the states where the homeowner's incentive to default could change more, because in non-judicial review states, foreclosure is not a very viable option even before the home price starts going up. The second prediction we are going to test is that there should be a larger effect in MSAs with more extreme non-SFHA risk. Remember that we already control for the underlying risk level. Here, we're going to capture the extremity of the risk, because only homeowners that are subject to risk seriously enough to threaten foreclosure would have incentive to change their flood insurance demand. And so we use this extreme risk measure, which is the number of non-SFHA properties at 1% annual risk divided by the number of all non-SFHA properties at any risk. And this is one area that I think really illustrates that it's so beneficial to use first risk measure, because here it allows us to build this measure up from the property level. Okay, so on the first prediction of the liquidity mechanism, we see essentially that there has been not a lot of change in the one-year renewal rate for either SFHA or non-SFHA policies. So this is not consistent with this mechanism being a main mechanism. Whereas when we look at the default incentive mechanism, so here the green line is from MSAs that have judicial review law, and the blue line is from the MSAs without judicial review. And in terms of home price, they have similar dynamics. In terms of flood insurance take-up, we see a huge divergence where the MSAs with judicial review laws respond much stronger. And similarly, if we look at MSAs with more extreme non-SFHA risk versus less, we also see a divergence. If we put it into a two-stage least square framework, then we see that states with higher judicial review, states with judicial review laws have almost double the response to a home price increase. And similarly with MSAs with higher risk. So I am running out of time. To conclude, we find that higher home prices lead to higher flood insurance take-up conditional on the value at risk. And we find that the most plausible mechanism for this relationship is that households now have a greater incentive to prevent defaulting on mortgage and losing the newly gained home equity. The implications from our results is that the decisions of at-risk communities to adapt and insure against climate risk will depend on their stake in their property. Thank you very much. I don't know if I have time to take questions.
I think just to be sensitive to time, maybe we'll let Scott present and then we can take questions together in the end.
Okay, yeah.
Thank you, Penny.
Thank you.
Scott, if you're ready, you can share screen and.
All right, I'm here.
Great.
Let me go ahead and get this started.
And one of the things that we had hoped to get out of this also was the structure of the presentations, and if it makes more sense to do one presentation per workshop or two, and it will sort of get our bearings based on this initial run through.
Can everyone see this?
Yes.
Or is it showing the full screen here? Okay, great. All right, thanks everyone. This study I'm going to present today is definitely not as complete as what Penny showed. This is very preliminary work using some of the First Street data. And I'd like to acknowledge my collaborators in the Flood Lab, most of who are still at ECU. I'm the only one that has jumped ship at this point, but so motivation, very similar. If you haven't checked out, I think this has gone around the circles, but this ProPublica online news story about counties and their climate risk. It's a great site. And one of the components of this climate risk is economic damages from climate 2040 to 2060. And what you see here is much of the counties along the coast of the Southeast United States is having high climate damage as a percent of GDP. So there's many reasons for this, and the article points to this, is that many of these counties are agricultural based, very rural counties, and they're at extreme threat due to a combination of things. First of all, sea level rise, flooding some of the areas, extreme rainfall and storms, and then intense heat, which is going to damage crops and lead to labor shortages as well. So we're going to focus on Eastern North Carolina, which is part of this grouping, and right here you see Terrell County that I've highlighted on this map.
Hey Scott, we're still on the first slide. We don't see the map yet.
You are? Okay, hold on.
Or I don't.
Can anyone else see it?
I think we have your PowerPoint presentation, but not the full screen.
Oh, okay. Let me see if I can forget how you do this here. Let me try this again. I apologize. Let's see. Let's try sharing that again. Is that better?
I don't have a shared screen now.
Oh, hold on. Apologize.
If it works, you could always show the PowerPoint presentation and just click through those slides. I don't know if that's.
Let me see. How about that?
We can see your PowerPoint. It's not full screen though. I don't know if it needs to be full screen here.
So it's not showing the animations or anything. You see the map?
Yeah, we see it. We're on your second slide now.
Okay, we'll just go it this way because
Yeah,
I'm kind of confused how this works. But hopefully now you see the map of Eastern North Carolina. Did that come up? Okay.
Yes.
So this is our study area, and we're going to focus mostly on these two counties, Terrell County and Beaufort County. A little information about these counties. They're very rural, low population. Terrell especially is pretty high in terms of percent employed in agriculture and percent living in poverty. So the question that I'm gonna pose is, is flooding more preferential in some of these agricultural landscapes using the API data, and then so what is the kind of the cost in terms of property values? Okay, so this is the data and methods slide, basically taking 3 data sets and combining them in GIS. The first is the flood lab information, flood zones, flood factor, adaptation, and historic indices.
You're not.
I hate to interrupt. We're on the
advancing.
second slide still.
Really?
Yeah. We see your desktop with the PowerPoint on top of it. I don't know if just clicking the slide.
Oh, yeah. All right. All right, maybe somebody needs to walk me through this. So I'm trying my share screen, but I don't know why it's not finding. Okay, here we go. I'm sorry. think this will work. Try this.
Yeah, there it is.
Okay. Do we have the full screen now?
Yep. Got
All
it.
right. Apologize for that. All right. So anyways, this is the data and methods, basically combining the flood lab information from Prop Geo NC, the North Carolina one map county parcel data, and the land use, land cover change information from USGS. So looking at the intersection of this in GIS. So moving on, so we don't make sure we don't run out of time here. You have to advance. All right. Are we on the next slide?
Yep.
Okay, great. So you should be seeing a Geo Earth image. Basically this is Columbia, North Carolina, which is the biggest city in Terrell County. And again, this is a small county, this is a small town. So these are the geolocated points of the API data for this area. Do you see the points on the map?
Yes. Mm-hmm.
Now this is the shapefile for the parcel information, and you can see good agreement, which is great to see since these are coming from two independent sources. Then what we did is we took the information from API and we ingested it, or basically joined it to the parcel data. And so now we have a spatial data set here. And then here's the USGS data that we're using. And if you go, oops, what way too ahead? Sorry about that. So go back and forth between these two, and hopefully that's toggling for you guys. Yep. You see a general good representation between the land cover that you see in this visible image and then what the USGS says is underneath. And there's 14 categories. I don't have them listed here, but they'll come up later. The brown is cultivated crops, and the light blue is wetlands, and the dark green is evergreen. The reds, pinks are developed areas. So the next thing I did was, in order to give each parcel an identifier for its land cover, I just took the majority. So if you go to the next slide, you see that now every parcel is covered by one single type of land cover. So kind of see that. We toggle back and forth here. So I think it does a pretty good job of capturing the majority of the major land cover type. Okay, so then zooming out into the entirety of Terrell County, if you can, let's see, if you can see my cursor, I'm not sure if you can, but basically Columbia is at the top of this county. And this county is under flood risk because it is very coastal. It's bounded by the Alligator River and the Albemarle Sound. You can see the majority, and I'll show a figure in a second, but the majority of land cover is this woody wetlands, with the second being cultivated crops, and that's shown here in this figure of total area. 28% being cultivated crops, 55% being this woody wetlands, and then 8% being evergreen forest. Very small amount is what we consider developed between open spaces, low intensity, medium, and high intensity. So this is the flood factor value for all the property in Terrell County. This is one of those counties that's missing some property information, some flood factor information that was mentioned earlier. But you can see the spatial distribution here. And then you can now start to combine some of these data sets. So this is average flood factor by land cover. And what you see is, well, a couple things. The good news is that the wetland areas tend to have the higher flood factor, so they must be in locations where they have some protective measure, being closer to the shore. Cultivated crops actually is lowest in this grouping, which is good news for the rural economy. Although all of these land surface types have fairly high flood factors, above 5. And then the concerning news, which is actually not surprising, is a lot of the developed spaces have the higher risk, have the higher flood factor, and that's because a lot of these areas are along the coast. So the next thing I did was look at property values. And the top one is the parcel value for all these parcels in Terrell County. 47% of the parcel values are in that cultivated crops category in the total value. Only 14% is what's considered developed. If you take this in terms of a value per area, you get the map that's shown down below. And I think this is probably more related to the flood factor. If you compare these two, and that's what's the graph on the bottom left, is looking at the average value per square meter based on flood factor, going from 1 to 10. And you see what you would probably expect is that it's going up. Although there's that dip at 7 and 8, I'm not quite sure what that is, but there's generally an increase of flood factor with property value per area. So the rest of this is going to be kind of just comparing that to Beaufort County. With Beaufort County's got many more properties. Like I said, it's much more economically sound than Terrell County, although still has issues. And it's definitely flood prone with the Pungo River and the Pamlico River being right at the boundaries, eastern boundaries. I didn't have the chart on the percentages, but you can see the higher percentages here are going to be cultivated crops in brown and in the evergreen forest in darker green. So here's the flood factor. Again, it looks like what you would expect with some of the higher values near the rivers and lower values as you go inland. And again, like was said earlier, a lot of this is based on storm surge. So you have that east to west kind of decrease in flood factor. And then this tells the same story as Terrell County. Basically, the flood factor is lowest, not quite lowest, but definitely low for cultivated crops, higher for the wetland areas, and again, higher for the developed areas. And here are those same figures in terms of property value and then property value per area. So unlike Terrell County, 26% of the total property value is under this cultivated crops category, farming, 31%, so a higher percentage is under the developed open spaces. And then if you look at the value per area, that's the bottom graph, it again shows a similar story. You have the higher values per area near the rivers, as you'd expect, and in the city is Washington. That's up at the very tip of the Pamlico River here. And then the average value per meter squared as a function of flood factor goes up, just as we were saying for Terrell County, with that dip at 7 and 8 again. Okay, then I know we're running out of time, but I kind of wanted to show a few things and kind of link this to a project that I'm working on with a couple of the investigators in the flood lab. But this is showing history. I was really glad to hear that Matthew and Florence are going to be added as historic storms, especially with the pluvial flooding. You'll see in a second. I mean, that's the kind of interest that we have is in compound flooding, and having that pluvial component is very important for what we're doing. But this again is I think mostly based on surge, looking at areas affected by Isabel or Irene. Isabel was in 2003. Irene was 2011. So either or both. The red is indicating both hurricanes affected these parcels. And you see Terrell County, which is essentially at sea level and easily flooded, is widely affected by storm surge. And then down below are a number of projects, adaptation projects from the API data set. And just kind of giving you a sense of where the projects are located geographically compared to sort of this historic flood events that have happened. So the First Street API will inform our research project, preparing for, responding to, and mitigating compound water hazards for resilient rural communities. If you don't know what a compound hazard is, it's basically the combination of multiple hazards that contribute to a societal, environmental, or health risk, and that's a compound event. And so we're really hoping that this API data will inform our second and third objectives of this project. The second objective being examining the physical nature and economic and health impacts from 2010 to present. And objective 3 being using this information to co-produce knowledge and tools for better preparation, response, and mitigation plans. So as far as the adaptation projects, one of the things that I was looking out for is whether the adaptation projects in the data record showed multiple sources of flooding, and they do for both these counties. In fact, it's one of the reasons I picked these counties initially was because they had adaptation projects that were compounding in nature. Basically, they were looking at both fluvial and tidal or surge-related flooding. And so for the fluvial, it's mostly levee creation, and for the surge and tidal, it's mostly wetland or living shorelines. So we had a workshop with this project in February, just before COVID hit. We were lucky to get that in. But one of the questions we asked was, what mitigation projects has your community, county, region sought after a flood? So mitigation, in this context, mitigation and adaptation are kind of interchangeable. So I kind of want to see how those, what the interview transcripts look like in terms of the mitigation projects that they're looking for versus what's already established. And again, I think pluvial is a category in here, but I never saw any pluvial adaptation projects for these two counties. And but you can imagine one thing you could do with this, and I think would be really interesting for compound flooding, is to kind of give a compound adaptation scorecard, right? So you could say, for this particular county, are they doing adaptation measures that are targeted to fluvial, tidal, and pluvial flooding? So I think that would be kind of interesting. And then the other thing that we're doing is using case studies to understand economic loss and health impacts. So one of the things that we may potentially be able to use either the flood factor value or the historic record for is to look at, well, actually in this case, it's more the historic records. And again, Irene and Isabel are currently the only two that are in the data set for this. I guess this is the early version of the API data. One of the questions we have is we want to know whether there's adverse health impacts are higher in affected counties rather than those that are not. And maybe we could drill down to the parcel level since we have this information rather than staying at the higher county level. So Dr. Azmita Ghosh, who I believe is on this call, is kind of in charge of the health impacts part of the project, and she could maybe answer more of the questions on this one. But this is some of the stuff that we're going to use to help to link the emergency department admits and the impacts from flooding from recent events since 2010. So I apologize for my technical incompetence at the beginning of this talk, but thank you for listening, and let me know if you have any questions.
And anybody, and I know we were only running to 4, so if anybody does need to drop, I just want to say ahead of time, thanks for joining. Brett's going to kind of wrap up and send a follow-up email on the workshop, and we'll plan for future workshops and make adjustments as needed. But we're around if you have questions about the data, and if Penny, Philip, Scott, or anybody else is around to answer questions, so we can sort of stick around as long as we need to for that. So
yeah, I will stick around if there are questions.
Thanks, Penny. Yeah, for those that are dropping, thanks for joining the workshop. Any questions for Penny and Scott?
This is Jamie Cruz. And thank you, Scott, my co-author, but I had a question for Penny. You alluded to the effect of hurricanes on take-up rate in your study. Did you control for that?
No, so we didn't explicitly control for occurrence of actual flooding or hurricane events. I think the implicit assumption we're making is that the occurrence of these events during our sample years are essentially random and not correlated with the occurrence of the booms. But we can, And we also have the risk by year control to sort of control a little bit of, for example, like MSAs with different risk level are responding to the hurricane events during those times. But no, we didn't explicitly control for it, and we can probably consider adding to it. It's probably going to help with power.
Any other questions for Penny or Scott? We also have with us Kelvin Liao, who wrote the API wrapper, the Python wrapper for the API data access tool. So if anybody has questions about that also while we're here, we're happy to answer those questions. The feedback we've gotten on that has been great. Kelvin continues to update it and make it more efficient and quicker. And it's terrific. All right. So it sounds like, well, there's a question that just came into the chat box, and I've actually asked Kelvin this a few times, and if we consider a R wrapper to extract data from the API. And Kelvin's sort of natural programming language, I guess, or what he programs in most often is Python, but we can definitely work on an R wrapper. I've been thinking it would be more useful to me. I write in R more often than Python, so maybe we'll jump on that and we can build that out.
This gets an upvote from me.
All right, but it doesn't sound like there's any more questions. I think they're great presentations, and I was impressed myself with how far along they are, and the fact they're moving right along. So I'm glad that we had this opportunity to share the information. Brett, did you have anything you wanted to say?
No, I was going to say thank you to Penny and Scott and Philip for presenting that. It was really fun to see the data in use, and appreciate you guys taking the time to do that. And appreciate everyone else staying on and joining the call.
Yeah.
Thank you, Brett, for organizing, and everyone at the First Street. Really, the data is really great.
Yeah, thank you, everyone. Is there time to ask a few questions about the model updates and stuff?
Please, yeah.
Sure. Great. So I saw you guys mention the average annualized loss, and that's so exciting. And one thing I've noticed working with the data, right, is that the first floor elevation of any given property is sort of like this key piece of data.
Right.
When you guys are going from the flood depths from the ground to the average annual losses, like what sort of imputation or data are you using to think about those first floor elevations?
Yeah, and our plan is to integrate that in a way that people can edit some of their conditions, because we know that the first floor elevation is really impactful in terms of what those flood damages look like. We're using, where it's available, the foundation type with the HAZUS methodologies translation from foundation type to first floor elevation. We know that's just our best guess. It's not going to be accurate everywhere. But then we're also using the U.S. Army Corps' National Structures Inventory database at the block level. So we're using that to get an idea of what the building codes are like in that area, and it comes with both the foundation height. So we'll take kind of like the average foundation height at the census block level as kind of our building code indicator, but we'll also take the modal foundation type, and we'll see if those align, and we'll use that to compute property level data where we don't have good information about the foundation type and the first floor elevation. So we're using, there's a lot of estimates based on fairly local building codes, but we are giving people the opportunity to edit those on flood factor.
Well, actually, I can keep going down a list here. Thank you for that. But if anyone else wants to jump in and interrupt me anytime. So then I also thought I saw in one of the bullet points you mentioned that you're updating flood zones with some LOMCs. I've seen, so first of all, just to make sure we're all on the same terminology, we're understanding, right? There's letters of map change, and there can be the ones that like change an entire section of the map, and then there's the individual, like a property level, like I as a property owner just get my property taken out of the floodplain.
Right.
And I've seen data on, you know, FEMA's website that seems hard to download and aggregate in a systematic way. Have you? So what all exactly are you guys getting into the model?
Yeah, and Kelvin, you actually extracted that data, I think. I don't know if you want to say a few words about what that all entailed and what we actually pulled.
Sure. So you're correct that we are using the FEMA dataset that they provided. We actually went through and downloaded each of the separate batches for the weekly FEMA updates that they have on their website. And that's why it's limited to, I think, 2016, or was it 2010? But we have the LOMA data for those batches for those specific years, and we did use, well, I used a bit of Python to clump it all together in one big batch and sent it over to the data team. And you are correct that it is the individual PDFs that property owners have sent over to FEMA and assessed, and then the updates were applied.
And that's what you guys have?
Yeah.
Yeah. That is
wow, thank you so much. I was about to I was dreading starting to do that at some point in the next year. I would like wake up with cold sweats about working those other. Thank you. Wow.
Well, Kelvin spent a few weeks with cold sweats working on that. So.
Another thing, I was just wondering your kind of like perspective on this. Another thing I've noticed, this was in particular in Miami. I would notice that I'd run into a lot of structures where it would be like even when they're in an SFHA, and it would be like zero risk. You know, just all the depths, everything zeros. I mean, is your perspective, is that just, you know, FEMA mismapping? Of course, like every model is noisy. There's always going to be disagreements between any two models. It's not that like FEMA's wrong and you guys are right. It's there can be discrepancies in models, but like in general, you know, how seriously should we think about literally saying like the risk on this structure is zero, perhaps with the usual caveats of like there's no such thing as no flood risk.
And that's in reference to the FEMA flood zone or our derivative statistics?
Well, it would be that like, so I would, you know, so I have a table somewhere, like I think it was a sample of about 1,000 homes in Miami. I paired them up, and I would see that, you know, even if you're in an A, B, SFHA zone,
right.
You know, a good 20% or so of those folks, like, you know, don't even have a 1 in 500 flood depth.
Yeah, we saw that. We saw it the other way more often, where we did find.
Sure.
Property.
Yeah.
But we did see. I don't remember the exact numbers. Mike had to drop for another call, but he did that analysis, and he knows exactly kind of what the reasons were and the numbers of properties that do show primarily an AE or some type of an A zone risk and not a depth. In our model, and one of the things, you know, the derivative statistics are run at the building itself as opposed to on the property. So it could be that the hazard layer just doesn't come into contact with the building. And, you know, that some of the, again, as you mentioned, some of the noise at the model at the 3-meter resolution. But Mike would be a good person to sort of contact on that. We have seen that, and we've talked with sort of the National Association of Realtors, the folks at FEMA. That's a question that's come up a couple of times is, you know, if we are showing people that they have risk, do we want to show them that they have a flood factor of 1, you know, as opposed to, you know, what's been modeled. So there's some way that we need to kind of think through the way we're presenting those derivative statistics as contact with the building structure, where there may be a lot of risk right outside of that buffer around the building structure. So we're working on things like neighborhood risk score. We're working on things like property risk score as opposed to just the building risk score. And that'll sort of add to a little bit of complexity, but a little bit more nuance to the way that we understand risk score. And maybe that would better capture, and we may see some better alignment in some of those areas. But the model as it's run now and the way that we extract the derivative stats, we don't see risk against the building.
Yeah, I mean, I'm very open to the idea that FEMA makes mistakes in both directions
Sure.
with their flood maps, and that's certainly the opinion of many homeowners who are angry about their mandates. But you know,
and that's what we're worried about.
Get your perspective on this.
Yeah. We were a little bit worried about that. We don't want to show no risk. If our goal is to promote awareness around flood risk, and if there is actually flood risk, we don't want to show that there's none given the way that we extracted statistics. So we definitely want to be careful about the way we message that outwards and sort of building out that risk score.
I'm wondering.
Thank you so much.
Go ahead.
I was just saying I'm done. So please.
I just have a quick question. So like with the discrepancy between the risk you calculate and FEMA's map, what would you say are the primary factors that make that different?
Yeah, and some of the, we were on with the TMAC, the Technical Mapping Advisory Committee at FEMA, and we gave a couple presentations there, and there seemed to be pretty good alignment around the primary differences that we saw tended to be further away from the coast. So the methods that are implemented in coastal regions tend to be newer maps. They tend to be on the ground sort of engineering studies and lots of V zones and things like that. The more inland risk is where we saw a lot of departure, and a lot of that's driven by the fact that FEMA treated and treats pluvial flooding differently than the way the modeling process treats it. So they tend to treat it as something that fills rivers and spills over rivers further downstream as part of their hydro process. We were using a rain on grid process where the higher elevation areas displace water to lower elevation areas. And that was a big part of it, was the fact that we were integrating pluvial risk in that way. And the other way was that if you've looked at the FEMA maps, there's generally a hard cutoff off of the main river channels. You can only go so far from the main river channels. And then if you actually look at the flood risk, it looks like sort of these tentacles that continue to spread out, but the main river channel for FEMA cuts short of that. So we're picking up a lot of creeks and tributaries and smaller river channels that the FEMA model doesn't pick up. They're designed for floodplain managers, for public safety and for understanding major insurance risk and major flood events. And ours are really around property level flood risk, so we pick up more of those smaller incidences of flooding along those smaller channels and pluvial events. I think that really there was a lot of agreement in that meeting with the FEMA folks and their modelers that's really where a lot of that discrepancy comes from.
That's good to know. Thank you.
Well, even
sorry, can I go ahead?
I was just going to say, even at the coast, the pluvial flooding is a problem because I think the coastal people rely too much on the surge modeling and on the river modeling, and don't think about the effect from rainfall. And so, especially in the area we're working with, East North Carolina. I mean, think about Hurricane Floyd. I mean, it's all low-lying area that can easily be flooded with. If you have, especially a precursor event that saturates the soil, you can have an event come in there and with just a lot of rainfall and just like flood the entire area. So I'm really glad you guys are putting a lot of attention on that.
Yeah, I just want to add, can you guys hear me?
Yes.
Yeah, I just wanted to add that we were comparing the FEMA maps for one of the counties in Washington with the flood factor data, and we found that a lot of FEMA maps, FEMA data does not reach it doesn't have a good reach in the unincorporated areas of the county. So definitely in terms of the reach of the data, the FSF data has been great with that. So we can actually capture the whole of the county. Like a number of mountain areas in Washington are not covered in the FEMA maps.
I actually had something here that I was working on earlier today. And I think that just because we're all here, but I mean the red are the FEMA non-X zones, and then these are our models, right? You can kind of see that they're mapped pretty well on the river channel. They're mapped on kind of these main river tributaries, but then there's sort of an abrupt stop, and the modeling keeps continues and along the smaller river channels. I think that's essentially what Pranjali was saying. So.
I have a question on the historical grids. Is there any sense of the uncertainty on those? And if we, say, had an external set of locations that we wanted to extract flood depths on, I mean, is it reasonable to pull the grid cell, a single grid cell? I mean, would it be better to average over some area? Just trying to get a sense of what the uncertainty is on those historical reconstructions.
Yeah, and is Michael still on? I don't think Michael Marston led our historic modeling process, and we did a lot of sort of calibration against high water marks and against FEMA claims in areas like in zip codes in terms of structures impacted versus what we show impacted. That we could probably produce from that some indicator of uncertainty, and in terms of how far and what's our expected sort of misalignment with the high water marks once we run the interpolation. I think we don't have an indicator right now of that, but I mean that's a great idea. Something that we haven't integrated into that product. I don't know what the best way to do that. If you want to, feel free to reach out on email. I think we can sort of take that and start to integrate that into our process and start to think about that.
Okay, great, thanks.
All right. Any other questions or comments or anything?
I had a question.
Sure.
This might be something that you guys don't deal with at all, but I just want to know that I'm not missing something. Do you have a way of calculating population exposure using the insurance data? Like, do you capture the use of a property at all?
Yeah, in terms of use type, is it commercial versus residential, et cetera? Yeah, I mean, we have that in our property level data set. It's not currently in the API, but as we're building out the AAL project, the use type is important to specify the proper damage function. So it probably will be part of the API build out as we move into the AAL project.
And this is for all the property in a particular place, or just those that are inside the flood risk area?
So it's for every property. In some places, the assessor data isn't very good, so we might have some missing data there. We do our best to compute it where it's missing, but it would be for all properties.
Yeah, for my analysis, I had to actually load assessor's data, so this would be really good. Thank you so much.
Cool. Any other thoughts or questions or comments? No.
I had a comment, like you guys are doing great in terms of how flooding should be analyzed, I feel. Certainly. I have had 3 courses so far. I just started with my PhD program, and I have had 3 courses where I have said that there is this data and everyone should look at it in terms of looking at flooding in a different way than what FEMA presents. And the response has been really good. So keep it up. Thank you so much for sharing this.
That's great for us to hear. I appreciate that.
Yeah, thank you, Pranjali. That's a very positive note to end on, I think. But thank you guys all for joining us. We appreciate it. And if you have any feedback, please feel free to email me or let us know. We definitely want to make these useful and improve them as we go.
Yeah.
So
maybe Philip and Scott for sure. Thanks.
Thank you, everyone.
Yeah,
Cool.
thanks. Thanks,
See you
everyone.
guys.
Yeah, thank you.
Bye-bye.
Thank you for organizing this.